Hi dear students, how are you all? Can you hear? How is your preparation? July is also going away. August, September, October, November, December, 5 months are there for full swing preparation. Even if 5 months is more than enough for your preparation, if you prepare with strategy. So we'll talk about preparation strategy for GATE and ESE, both the exams, in the subject of strength of material. So you need to show your strength with this subject. So strength of material, and it is a fundamental subject for almost all the analysis and design type of subjects. After engineering mechanics dealing with rigid bodies, and this is dealing with deformable bodies. So after engineering mechanics, this is the important subject for you. The conceptual subject, important subject, and most of the questions which are generally coming on the basis of logic only, with a little fundamental. We'll look into the solid mechanics. This is the syllabus given for the GATE civil engineering. And you see, look at this 6 lines of syllabus. Whether it is 6 lines or 4 lines, the content is same. And this is mechanics of material for mechanical engineering people. You see, actually the syllabus is almost the same, but extensively given, elaboratedly given here in the mechanical GATE point of view. And at the same time, solid mechanics for civil engineering ESE, only just 4 lines, almost actually to say it is a bit more than that of the GATE syllabus. Actually GATE is a subset of the ESE syllabus, you can say. Now this is mechanical ESE syllabus, again 4 lines, slightly extending more than 4 lines, but the content is same. So the weightages we'll talk about, in detail we'll go for the syllabus and what are important, what are the areas which are important for us, we'll discuss a little later. So coming to the civil engineering, GATE point of view, you will get a weightage of 7 to 9 marks. 7 to 9 marks, a good weightage out of 100, 7 to 9 is a good weightage. You need to concentrate on this subject. Even if you casually prepare, only the main topics if you prepare, if you are getting total of 9 marks for example, you can touch maximum 6 marks. So around 70 to 80% with casual preparation also you can do it. If you have accuracy in solving the problems, accuracy in using the online calculator, and if you are strong in units and all, and if you are reasonably good in your engineering level. Coming to ESE prelims, 18 to 20 objectives, very good weightage for ESE point of view. It comes under paper 1 for civil people. So 18 to 20 objectives out of 150 is a very good weightage. Coming to ESE mains, 40 to 100 marks. In some years, in few years, even the total marks exceeded somewhere around 110, 114 like that. But however, very good weightage will come from ESE. Usually, if you get more marks in strength of material, there will be less marks in structural analysis for civil point of view. If structural analysis weightage is reduced, then they increase the weightage in the ESE mains. We will completely talk about prelims and GATE point of view. Mains will talk about after prelims, because main strategy is completely different and it is completely not in the present talk, because mains comes only after the prelims. The people who are preparing for ESE mainly or ESE only, you just prepare for prelims now, then you can concentrate and focus on mains later on after the prelims exam. If you are writing the GATE exam, So after the GATE and ESE prelims, you can start your preparation for the mains. It is not a big task because you have only the conventional paper, something similar to your semester papers, as you do it in all 4 years. Now coming to the mechanical engineering, the weightage is the same as that of GATE civil, you see, 7 to 9, here also 7 to 9. Sometimes it may extend to 10, but extending to 10 marks is a rare issue, very rare issue. And ESE prelims point of view, 10 to 15 objectives. Compared to civil, 18 to 20, this is slightly lesser because here the design, machine design and theory of machines will be sharing some complex stresses problems complicatedly. And mains point of view, 50 to 65 marks. It is reasonably good weightage. So mains, we'll talk about it later on. We'll presently discuss the strategy for GATE and ESE prelims point of view. And especially people who are exclusively preparing for GATE exam, don't touch ESE prelims now. And people who are exclusively preparing for ESE prelims, take GATE on a lighter manner. If you are preparing for both, you need to concentrate and spend more time because you need to master on both the patterns. Now coming to the GATE syllabus, we'll talk about the GATE civil first of all, and then we'll move to the GATE mechanical and then to the ESE and all. So if you look at this syllabus, bending moment and shear force in statically determinate beams. Indeterminate comes in your structural analysis. This is just determinate beams. Deflections and propped cantilevers. These are all comes under one category. Definitely there is a chance of 2 marks question from this area. More than 2 may be possible, but minimum 2 marks will come from this area. So SFD, BMD, slopes and deflections and propped cantilevers. For shear force and bending moment diagrams, SFD and BMD point of view, you need to concentrate on the basic cases. The simple cases will be there, na? So cantilever with point load, cantilever with a couple, or simply supported beam with point load, central point load. Those things, all standard cases you need to rut. You need to by heart. That should be there in your fingertips. And then deflection standard cases also you need to rut it, because those deflection equations may be used as compatibility for your propped cantilevers. So most probably there is a high chance of getting a question on propped cantilevers for civil point of view. And that propped cantilevers you can analyze by the basic deflection formulae. And SFD, BMD, especially if you are preparing for a ESE prelims or a GATE exam, don't practice very, very big lengthy questions of drawing SFD, BMD. Even though you are mastering in drawing SFD, BMD complete diagrams, it may be sometimes waste for you. So what do you need to do is bending moment at a section or shear force at a section, you should be in a position to calculate after calculating the reactions. First you calculate the reactions, practice on reactions of the beams, support reactions, and then shear force at a point or a section, bending moment at a point or a section they are asking you. And in ESE point of view, simple standard cases, SFD, BMD, they are asking you to identify from the options. So in SFD, BMD, standard cases, RUT2, then SFD, BMD only to the point. To the point. Wherever bending moment is there, wherever shear force is there, at a section calculations. That is easier version. There you need to concentrate more. Okay, you understand? And the civil point of view, try to concentrate conversion from SFD to loading diagram. That is very easy. And then conversion from BMD to SFD diagram. That is also easy. They won't ask you to completely draw loading diagram from SFD. They won't completely ask you to draw BMD from SFD. So with slight logic, by if it is a multiple choice MSQ question, by process of elimination, you should be in a position to pick up. If you identify few standard fundamentals of SFD BMD, then you can do that with ease. So here practice is required. Practice makes everybody perfect. That's the main criteria. That is regarding first part of the syllabus. Coming to the next part of the syllabus, the simple stresses and strains and relations. So from this, there is a chance of a 2 marks question. Simple stresses and strains. The theory is there, the stress strain curves and various points on the stress strain curves. You just glance through, because in theory, by looking at the multiple choice questions, multiple choices, you can identify the right and wrong options by process of elimination. So don't spend much of time on theoretical concept in gate preparation. So stress strain relations, nothing but the generalized Hooke's law and calculation of volumetric changes and the relation between all the elastic constants, E, Young's modulus, rigidity modulus, bulk modulus and Poisson's ratio. Questions on that, there may be a choice. And the composite members are important for us. So if you look at the previous year questions of the GATE, especially the people who are preparing GATE civil, you try to solve the GATE mechanical questions also of the similar area, because the syllabus is almost the same, except the mechanical properties. Leave the mechanical. Civil people leave the mechanical properties, and mechanical people you need to concentrate on the mechanical properties and theory on that. So civil people not that much required. So try to solve GATE mechanical also, especially the numerical questions, then you get the confidence. And sometimes you might have observed some GATE mechanical previous year questions are appearing in civil with little change. They won't reprint the same question, concept repeats especially. Next is, if you look at the third part where there is a chance of 2 marks, so this area, simple bending or pure bending, flexor and shear stresses. Shear center, only the basics of shear center definition and the location of shear center for various sections, if you remember, more than enough. Otherwise, shear center for that channel section, that formula is there, that if you remember, more than enough for your preparation. So location of shear center for various sections and the formula for the shear center of the channel section, and the definition is enough. And the other is bending stresses, shear stresses. So bending stresses and shear stresses, flexural shear stresses are important for us. So direct questions are coming. Usually they are linking the SFD BMD with this. They'll give you beam and they're asking you, they're giving a section. At that particular section, they're asking you bending stress or shear stress. That means you need to calculate bending moment or shear force at that point of the beam. Then you need to calculate, especially formula oriented. Derivations are not required. Formula are very important. Assumptions are very important. Formula are very important. And if you have time, just glance through the derivation through any of the textbooks. Because derivation may give you a sort of idea how the formula is being derived, but don't rut the derivations. Derivations are only to have clarity on how they are proceeding to get the final answer, and assumptions are required. Based on assumptions, there may be a chance of theory question. Then uniform torsion. Torsion is important for mechanical people. Bending and shear is important for civil people. So civil people concentrate more on bending and shear, flexural shear. Mechanical people, torsion. Even if a question is coming to GATE civil on torsion, that is a simple formula oriented question. And mostly the previous year questions are getting, the concept of the previous year questions are getting repeated in the next coming years also. So not much criticality is there. Next, transformation of stresses. This comes the concept of the principal stresses transformation of stresses, stresses on inclined planes, principal stresses are there in our syllabus. So transformation of stresses they are saying, strains they are not saying. So in the syllabus of GATE Civil, they are saying transformation of stresses. That means principal stresses, stresses on inclined planes, and the conversions are important. Mohr circle is important. The special cases, nobody will ask you to draw the Mohr circle. The special cases of Mohr circle is required for us. So that in case of criticality, you can get the answer directly or indirectly from the Mohr circle. Like that you need to practice. So transformation of stresses, nothing but principal stresses and stresses on inclined planes. Strains are not given. That's why you won't see the questions related to strain conversion, strain transformations in the GATE Civil. This point you try to remember it here. Buckling of columns, only buckling of columns. The buckling of column, that means long columns, nothing but Euler's theory. Only Euler's theory of long column is there in our GATE Civil syllabus. So formula based, and sometimes they are linking with the temperature, sometimes they are linking with other axial forces and all. So buckling of columns, Euler's theory, you concentrate. Other theories, you just leave it. Next, combined direct and bending stresses they are asking. The combination of direct stresses and bending stresses. Nothing but P by A plus M by Z, plus or minus M by Z. On that area, questions are coming. Go through the previous year questions, and similar questions you practice. Especially, you need to practice on the how many areas? 1, shear force, bending moment, and slopes and deflections. Next is simple stresses and strains. Next is bending stresses and shear stresses, the third area. Next is the torsion, uniform torsion. This is our fourth area. And transformation of stresses is the fifth area. Euler's buckling of columns and direct and bending stresses together is the sixth area. So 6 areas, if you are perfect, you can get 9 marks. So 6 areas, there is a chance of getting either 1 mark or 2 mark question from these areas. Either 1 mark or 2 marks. So 6 areas, you just concentrate. Leave all derivations. Now coming to the mechanical syllabus. In the same way, mechanical syllabus is also divided into various parts. You see, the first is stress strain, elastic constants, and Poisson's ratio. This comes under simple stresses. This is the first part. Again, the same previous year questions you need to go through, and civil questions also you need to solve. So take the previous year question booklet of your friend, a civil friend, tear out the pages of strength of material, and you go through. And the pages you return it back to your civil friend later on. So civil people solve mechanical questions, previous year questions of similar exam. Mechanical people try to solve civil questions. Next is they have the Mohr circle, they have clearly mentioned here, because the Mohr circle for plane stress and plane strain is also mentioned here. Strains are also there. Mohr circle for stress and strain. For strain is not there in our civil syllabus. So this here, the transformation of stresses, transformation of strains, everything will be there. Even strains and stresses on inclined plane, you need to concentrate. Strains also you need to concentrate. Once you have idea on stresses, very similar to stresses, you need to focus on strains without much of difficulty. It's very simple. Only the shear strain you need to, in place of shear stress, you need to take half of the shear strain. That's all. That is the only difference. Now, the thin cylinders is the extra topic. What is there in mechanical syllabus? Thin cylinders. Thin cylinder, the syllabus is very thin, PD by 2T, PD by 4T, and the corresponding strains, not having much of difficulty in solving this. The thin cylinders, only cylinders in syllabus. Spheres, thin spheres are not mentioned in the syllabus, and thick cylinders and spheres are not mentioned in the syllabus. You can leave them directly. If you are going beyond the syllabus and study, Your knowledge may increase, but marks may not increase. That point you need to keep it in your mind. Next, the same as the civil, the shear force and bending moment diagrams, which is given in green. And next is deflection of the beams. This comes under one set. Because they won't ask all the simple cases of SFD, BMD and the simple cases of slopes and deflections, you need to rut. And then similar to civil people, bending moment at a section, shear force at a section is very much required. And reactions also you need to calculate by equilibrium equations. Practice more on that area. Don't spend time on solving big questions. Take a big beam with a different loads and drawing SFD, BMD. That may be a time waste process for gate preparation. And mains of ESE, that is okay, but now it's not good. It's just waste of your time. Next is bending stress and shear stresses and shear center, recently included in our mechanical syllabus, same as the civil syllabus. This is another set, what I am rounding with blue color. So bending stresses, shear stresses, the formulae and derivations you just go through once, glance through once. Shear center, the shear center for different sections and its definition, more than enough. No need to go for derivations and finding out shear center through derivations. Takes time because all standard cases only they have to give, they'll give you standard formulae. They have their standard locations of shear center. Now torsion of circular shafts is important for us. Torsion of non-circular shaft is not there in our syllabus. So only torsion of circular shafts. Very important. There is a high chance of question on this area because the machine design and most of the machine design, you need to use this torsion concept. So mechanical people are strong in torsion. Civil people are strong in bending because their beams are bending members. Now Euler's theory of columns, again here clearly mentioned. There in civil buckling of columns, but here Euler's theory of columns. That means only long columns. So long columns, Euler's formula, if you remember, more than enough. Combined direct and bending stresses are not there in the gate mechanical syllabus. Combined bending and direct stresses are not there in the mechanical syllabus. Energy methods, especially the strain energy methods, to calculate the deflection is required for us. The deflections, any one method you try to practice, any one method or the basic cases of slopes and deflections you need to practice. Nobody will ask you in objective type of question, nobody will ask you, find out deflection of the beam by conjugate beam method, find out the deflection of the beam by strain energy method. But deflections, try to practice on strain energy methods. That is easier approach. You can easily calculate the deflection for frame type of members. Even frame type of members are coming for mechanical gate. So strain energy methods are important. Apart from strain energy method to find out the deflection, my suggestion is go for conjugate beam method. Just use the conjugate beam method, draw the conjugate beam and find out bending slope and deflections. That is a easier approach. My point of view, double integration method, Mechel's method or even moment area methods are slightly complicated. Moment area method is easy for finding out slopes. Maybe sometimes giving you very critical things for finding out deflections. You need to deflect too much to find out deflection of a beam by moment area approach. So moment area approach concept you need to go through, just how can you calculate slope and deflection, even double integration also. But practice, you make it on strain energy and conjugate beam method. Thermal stresses is specially mentioned here. That's why questions are coming exclusively on thermal stresses. This is a part of our first chapter. Simple stresses, temperature changes. And strain gauges and strain rosettes are extra area given to the mechanical people. These are all extra. Whatever is given in white, which is not underlined here, is, I am underlining with the blue color now, is testing of materials with universal testing machine and testing of hardness, impact strength. These are all theory. This will be covered in your material science also. So this theory, there may be a chance of one theory question. Glance through. Theory, even if you glance through, finding out answer through ABCD is easier approach. So how many topics totally? One. Next is, one is simple stresses along with the thermal. Second is the Mohr circle, nothing but complex stresses. Next, thin cylinders, I don't consider it as one part. Shear force and bending moment along with the deflections is the third one. Next is bending and shear stresses, same as the previous fourth one. Next is torsion on circular shaft is the fifth part. Euler's theory of columns. Energy methods, I don't make it separately. I am linking with slopes and deflections. Slopes and deflections are linked with SFD BMD. That is one part. There may be chance of 2 marks from that area. Next, strain gauges, strain rosettes. These are all theoretical parts. Maybe I can take it as 6. 6th is the theory question. So, in 1, 2, 3, 4, 5 parts, there may be chance of at least one question, minimum of 1 mark. So, concentrate only solving the problems of similar kind of exam. For that, you need to practice on similar questions. So, mechanical people solve civil previous year questions, and test series is very important for us. Test series is very, very important for us. Even though you are not having full concept, don't wait till you attain the full concept. Parallelly, you try to go for the test. Even though you are getting 0 marks in the test or negative marks in the test, don't get frustrated. Don't get low by that marks. Slowly, you get up and reach to the top. Even if you ask the toppers, they'll say their topping the exam is because of tests only. So practice is very much required. If you want to become a good cricketer, you need to go to the stadium and play cricket. If you just watch cricket in the TV, you may not become cricketer. So if you want to get good marks in the GATE exam, you need to practice similar exams, nothing but practice tests. And slowly there you need to practice and get the confidence. So practice and tests very much required. Next, coming to civil engineering ESE. Again, the syllabus is same as GATE, nothing special. Elastic constants, stress, plane strain also there, and Mohr circle. Actually, elastic constants is nothing but our simple stresses chapter, the first chapter. Elastic constants, their relations. So, along with the thermal stresses, you need to practice. Next is whatever is given in yellow is our complex stresses. You see, the complex stresses along with the Mohr circle is occupying more space in the syllabus. That means the question setter, after looking at this syllabus, including theories of failure, they'll focus more on this and they'll try to set more questions on this area, you see, a big area. So, in ESE point of view, concentrate more on complex stresses and strains also here. More circle of stress, more circle of strain also. Next, as usual, bending and shear stresses. Bending stresses and shear stresses. Same as the preparation of GATE exam, but here simple questions will come. Simple numericals will come. Without calculator, you should be in a position to solve them. If a very critical question is coming that you can't solve with calculator, just leave it. There will be bouncers. If bouncer is coming, what the people will do in cricket? they leave it free left. Will directly go to the hands of the keeper without any touch of your bat. Here also the same thing. So bending, shear and torsion, I am all together making it as a single unit. Next is SFD, BMD and deflections, another unit. So simple cases of SFD, BMD and deflections, you need to RUT, and the other cases are bending moment at a section, shear force at a section, even deflection at a section, deflection at a point, slope at a point. So for this, mainly, especially ESE point of view, going to the methods may not be that much recommended. For deflection, strain energy method is good method, and then conjugate beam method is a good method. So no need to practice much on double integration and moment area methods and other methods. Okay. So 1, 2, 3, 4 parts you can have. So first one is simple stresses, first chapter. Second is the complex stresses part. Third one is bending, shear and torsion. Next is SFD, BMD and deflections. That's all. So theory point of view, you get less theory in your class notes, and even if you read the textbooks, you get less theory. But the theory points, you will get it through the previous year questions. Each and every statement of your previous year ESE prelims questions will be a good fundamental gainers for you. So try to go through the previous year questions once or twice, and each and every statement you need to retrospect once or twice. So that is required. So after solving objective questions of theoretical objective questions of a particular chapter, you will get a complete overall picture of that subject along with the theory. So don't think that where should I concentrate theory. Concentrating theoretical points may not be possible directly through your class notes or through textbooks. That may be there, but picking up that points will be difficult. So those points you can identify and keep it in your mind through the questions, objective questions. That's why solve the previous year prelims questions of mechanical plus civil. Even though you are mechanical, solve civil. Even though you are civil, solve mechanical. And test series is very important. Test series is also aimed to give the same type of questions whatever you get in the exam. So test series is very important for your success. So 4 areas. But lengthy numericals don't solve. Lengthy derivations don't touch. Theory plus little numericals, whatever you can solve it by hand calculations, more than enough. And during your preparation of ESE prelims, try to solve the questions without much of difficulty. That means you need to round some numerical values to get to pick up the options. You have multiple choice questions everywhere. Among the 4 choice, you need to pick it up 1. So nearest answer, you need to pick it up by rounding off. See, if the options are very close by, then you have to be very careful in the calculations. If the options are very far away with a long gap between one option to the other option, then approximating and picking up the answer will be easier for you. So that comes with practice. Simplification with hand calculation without calculator is possible with practice. So finally, practice makes not only men perfect, monkey also becomes perfect with practice. So practice is required. Try to practice. So read the concept, go through once, then try to solve the similar problems, routine, required problems. So for going through your class notes, you need to take 1 or 2 hours for each and every chapter, first time. Second time only half an hour, third time only 10-15 minutes glancing through. But spend more and more time on solving problems. So in this process, the formula, strength of material, very few formulae will be there. Those formulae, you write it on a separate notebook, write them every now and then, revise them, brush up every weekends. Next is the ESE mechanical syllabus. Again divided into the different colors are there. You can look into the stresses and strains, compound stresses and strains. Stresses and strains are nothing but simple stresses and strains. Next, compound stresses and strains are nothing but the, the stresses on inclined planes, Mohr circle, principal stresses and all. This is the second part. Bending moment and shear force diagrams along with slope and deflections. So, simple direct cases you need to go through, and then bending moment at a point, shear force at a point, deflection, slope at a point. Easy questions will come, but sometimes lengthy questions will come. Lengthy questions maybe, I told you, maybe something like bouncers. You need to leave them in the first or second rounds. You need to solve ESE questions by round robin system. First round all easy questions, second round next level questions, third round critical questions if time is available, otherwise leave them. Negative marking will be there, na? Be careful about that negative marking. Next, thin and thick cylinders, spheres are also there. You see here. Thin and thick cylinders, thin plus thick cylinders, spheres are also there. This is there only for ESE mechanical. Concentrate on this because most of the boilers, most of the, IC engine combustion chambers will be thick or thin, maybe cylinder or spherical. So, you need to concentrate on this area. Next is theory of bending stresses and torsion. This you can say it as one separate topic. Theory of bending stresses, shear stresses also to be added, and torsion. So, shear stresses are not mentioned, flexural shear. That's why less questions are there in ESE mechanical. Sometimes what happens is the question setter may not see the syllabus perfectly, may not analyze the syllabus perfectly before setting the question. So, sometimes they may give you question on shear, flexural shear also, but concentrate on these main areas. So, totally the simple stresses chapter along with temperature, this then compound stresses, second topic, bending moment, shear force, slopes and deflections will be our third topic. Next is theory of bending, flexural shear and torsion is our fourth. Next is thin and thick cylinders, fifth. So, material properties and all you need to go through as that will be useful for you in paper 1, as well that will be useful for you in material science, especially for mechanical people. So, my suggestion is practice, 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 practice. Just go through the things from your class notes. Don't refer too many books. Too many cooks may spoil the dish. That already we know. That's why class notes, believe on class notes, and then try to solve more and more related questions. And while going through the class notes, short notes is important. Make it short only with formulae. Strength of material throughout should come in 4 to 5 pages. And in that 4 to 5 pages, mostly you might be having standard cases of SFD, BMD and standard cases of slopes and deflections. Otherwise, just simple things. Okay? So, this is what I wanted to make you alert. So, you have 5 months of time available with you. So, in that 5 months of time, you need to clear all the syllabus in 5 months. During the 5 months, you need to revise the syllabus also. Say suppose in the first month you might have studied something. Our mind is so volatile. Whatever you try to keep it in your mind may evaporate with the time. So, to avoid evaporation, what you need to do is you need to refill. How do you refill? With revision. You need to top up with revision. So, revision is a must. Revision is a perfect thing, whatever is required, and at the same time practicing tests on similar questions. practicing on similar questions. For ESE prelims point of view, if you try to solve the big questions of Ramamrutam, Pumya or Kurmi, it is time waste. So, solve similar questions. And theory point of view, most of the people, most of the students, they are coming and asking me, sir, where to find out theory? Where should I read? Where should I go through? So theory, don't make it as a separate thing. The theoretical points, whatever you get is through your previous year questions only. All the theory based questions you just glance through, those are all very important things, because if the question setter wanted to set a new question, they'll depend on the previous year questions only, because a person wanted to set a question on a particular area, what he'll do is previous year questions of that particular area he'll go through, and he'll try to set in that particular manner if he's a new person. And old people will have already used to that type of questions and preparing such a type of questions. They won't worry much, they'll set in the same lines. So that's why GATE point of view, theory is not that much required. ESE point of view, theory is very important, where you can save time and at the same time you get good marks. And ESE point of view, numericals, be careful. Try to solve numericals only at the end, in the round robin system at the end, because unless otherwise you solve, you may not know what is the complexity in the simplification. Sometimes the question setters, they'll give you the data in such a way that it won't converge to a rounded answer. They intentionally give you to waste your time. So such questions may be there in the numerical. That's why don't solve them in the initial stages. In the initial half an hour or 1 hour, don't solve numerical questions. You solve them in the last 1 hour or last half an hour of time. 1 hour to half an hour of time. Very critical numerical questions, better you leave it. Leaving a critical numerical question in ESE prelims point of view is a requirement. GATE point of view, lot of time will be there. Time is not a constraint in GATE exam, because for each 1 mark, 1.8 minutes of time will be there. For 2 marks, 3.6 minutes of time will be there. Time is not a problem in GATE. Time is a big problem in ESE prelims. So keep a watch on time, and then you need to successfully complete all the questions of the prelims. So watch on time in ESE prelims. Accuracy is important in GATE exam. With this, I am stopping here today. So we'll meet in the next class with the important questions of each and every area, whatever you have discussed now. So I wish you all the best. Thank you very much. Thank you for spending your time. If you like this video, forward to your friends, like this video. Thank you very much.